Welcome everyone, this is our line following Jetbot.
Hi guys, my name is Pham.
Hi, I'm Clarence Fultz.
And my name is Aravind Gnanasekaran. This is our autonomous vehicle lab final project.
In the lab one, we learned two objectives. One is to set the basic motion of the Jetbot, and in order to do that, we have to learn about Jupyter Notebook and Python programming language, and how to connect them to the Jetbot, which will essentially allow us to communicate and later on set the Jetbot into basic motions such as moving forward, turning right, and turning left. So during that objective, we also learn how to manually set the robot into motion by changing the speed of the wheels and how to calibrate those and set them into the motion of turning left and right. In the lab 2, one of the objective is path following feature, and in order to do so, we had to develop a closed loop PD controlling system in order to stabilize the robot while it performing the feature, the path following feature. However, in order to do so, we had to process a Jetbot camera image by calibrating it on the HSV scales. Furthermore, another objective that we were able to achieve is sign recognition, in which we had to make the robot cameras take dozens of pictures and train them, compile them all in one model, and feed it to the robot after processing it, so that it can recognize and understand the different road size and perform different function accordingly to those road size.
For the networking and communication objective, the robot will access the CeilingBot's microcontroller by entering the IP address of that robot to connect that robot to the Jupyter Lab notebook. Then we can extract information from the CeilingBot and send that image back to the Jetbot using the IP address of the Jetbot's microcontroller. This will allow us to communicate back and forth through each robot and transfer information. For the path planning objective, we use MATLAB to run the path planning code for the CeilingBot. This is achieved by using the MATLAB engine API on Python, which will allow us to run MATLAB within Jupyter Lab. The program uses current location and the end location, which is determined by us, to find the shortest path possible for the robot to travel. This is done by processing the image from the ceiling to a black and white image to use as a coordinate system using pixels. Then the program will recognize where the robot is able to travel by recognizing the white sections as road and black sections as the surroundings. Then a red line is processed by determining the shortest path available for the robot. For the camera calibration and position detection process, the image is processed from the ceiling to go from a fisheye image to a flat image where we can use a coordinate system. This is also converted to a black and white image to use as a coordinate system using pixels. The robot has an April tag that will be detected by the CeilingBot to determine the current location with respect to the coordinate system that is processed in the previous camera calibration.
This is the image that the Jetbot receives from the CeilingBot via networking.
So for our robot flowchart, we start off by having two inputs. We have the CeilingBot JPEG image right here, and the robot end position right here. The CeilingBot JPEG image is determined by the fisheye camera on the CeilingBot, and then the robot position and end location is determined by a point that we choose, and also the April tag on the robot, which is also determined by the fisheye camera on the robot. So the JPEG image goes through a conversion, pixel to real scale, and then it gets thrown into the path planning subprogram, which will then output a probabilistic roadmap, which will then find out what the shortest path is right here. So once that is determined, the shortest path is determined, all that information is networked to the Jetbot, which is in this subprogram right here. So once we get the information to the Jetbot, it will then go through the path following subprogram, which will have the front camera JPEG as an input, and that will also be an input for the sound detection. So these two are working at the same time because as the robot is following the line, it will also have its trained model up and recognize the stop sign or an intersection sign. So for the path following, it will use a PID controller, which will keep the yellow lines right in the middle. We have adjusted our KP and KD values to make sure that the robot does not overshoot the line or does not zigzag if it's too responsive, to make sure it's a smooth following. And then sign detection, we have a trained model that is uploaded to our code so that it will recognize each different signs. So for the path following, obviously it will go left, right, or straight. For sign detection, we will have the output be pause, slow down, straight, or turn right, depending on what sign you have. And those two will be the end of the flowchart for the robot.
The task our team wanted to complete was implementing all 6 features into our Jetbot. Despite not accomplishing this, we did implement 4 of the 6 features, consisting of kinematics, networking, sign detection, and line following. One issue our team had was reliably detecting the sign, which meant there was way more time spent on this feature. We dove deep into the code and did research and troubleshooted many problems that we had. Because of this extra time we spent on sign detection, we can firmly say anyone on our team can effectively modify and construct a model for projects in the future. As for the other 3 features, they were implemented to the Jetbot with relative ease, mostly requiring small changes like adjusting the HSV values or hard coding the IP address.
So here's our robot in action. As you can see, the robot recognizes the stop sign, it stops, and then it goes forward for a certain amount of time. And then it goes back to following the line. And as it recognizes that sign right there, it speeds up past the intersection. Thank you for watching our video. Here's a funny video of a robot when it was not working like it was supposed to do.
Why the hell?